Artemis 2 is over. The capsule came home, the crew walked out alive, and the cameras moved on. But the story you saw on the news was not the whole story. There were three things the four people inside that spacecraft did not say out loud. Not in the press conferences, not in the post-flight interviews, not in the smiling waves from the deck of the USS John P. Murtha. This is the story of the three things the Artemis 2 crew did not lead with when they walked off the recovery ship. Three physical realities of being out there, beyond the protective shell of Earth, that the rest of us almost never hear about. Before we get to them, you need to understand where they actually were. Artemis 2 was the first crewed flight of Orion. The capsule rode a Space Launch System rocket out of Kennedy on April 1st, looped around the lunar far side on a free return trajectory, and splashed down off the coast of San Diego on April 10th. At their closest approach to the Moon, they were about 4,070 miles above the surface. At their farthest from Earth, they were about 252,760 miles out, more than 1,000 times higher than the International Space Station, farther than any human being had traveled from home since Apollo 17 came home in December of 1972. They did not land. They did not orbit. They swung past the Moon like a stone on a string. And during those 10 days, their eyes did things no astronaut has had eyes do in over half a century. To put that distance in something you can feel, picture a coast-to-coast drive across America. New York to Los Angeles is about 2,790 miles. The Artemis 2 crew, at maximum distance from Earth, was roughly 90 of those drives away from the nearest gas station, the nearest hospital, the nearest other human being who was not also strapped into that capsule. If you could drive a car at highway speed in a straight line out to where they were, it would take you about half a year, around the clock, no stops, to get there. They got there in about 3 days. The Space Launch System threw them out of low Earth orbit at over 22,000 miles per hour, faster than any object near Earth that day, and then gravity did most of the rest of the work, the Moon's mass pulling them around in a wide arc before flinging them back home. That orbital mechanics detail matters for understanding what they saw, because the free return trajectory is not a stable orbit. It is a slingshot. They had one chance to look at everything. They could not loiter. They could not turn around. From the moment the translunar injection burn finished, their path was set. Whatever they saw it once, in the order the geometry handed it to them, and the spacecraft kept moving. The first thing they did not advertise is that the universe was writing on the inside of their skulls. Out beyond Earth's magnetic field, there is no shield. The magnetosphere is the invisible thing keeping you alive right now. It deflects charged particles from the sun. It absorbs cosmic rays from supernovae light years away. Inside that shield, you barely notice. Outside of it, you start to notice immediately. The Apollo astronauts were the first to report it, and they all reported the same thing. When the cabin lights went off and they closed their eyes to sleep, they saw flashes, not steady glows, not dreams. Sharp, bright streaks and dots of light flickering across the inside of their eyelids. Some of them looked like camera flashes. Some of them drew a quick line across their vision and vanished, like a comet seen from inside the head. Those flashes were not in their imagination. They were watching individual cosmic ray particles, atomic nuclei moving at nearly the speed of light, slam through their retinas and into their visual cortex. Every flash was a single particle so energetic that the brain registered its passage through living tissue. Most of those particles had come from supernovae that exploded long before the Sun ever existed. Some of them were older than the Earth itself. They had crossed light years of empty space for billions of years, and they ended that journey by crashing through the eyeballs of 4 Americans in a metal capsule near the Moon. To grasp how fast these particles are moving, consider the speed of light, which is about 186,000 miles per second. A typical cosmic ray hitting the crew was traveling at something like 99% of that. In 1 second, that single particle could circle the Earth more than 7 times. It is carrying so much energy that when it strikes a single atom in the retina, the impact cascades through nearby cells and produces enough activation in the optic nerve to register as a visible flash, even though no actual visible light entered the eye. The brain interprets the signal as light because that is the only language the visual system speaks. The Artemis II crew had been briefed to expect them. They knew the science. And in the quiet hours, when the cabin was dark and they were trying to sleep in their sleep stations, they watched their own brains being struck by the universe at a rate of several flashes per hour. There is no photograph of that experience. There is no clean way to describe it on camera, so they mostly did not. The flashes are also not evenly distributed in the brain. Different astronauts report seeing them in different parts of their vision. Some see them mostly when their eyes are closed. Some see them with their eyes open, faintly, against the dim cabin lighting. The particles do not care about the orientation of the eye. They are passing straight through the spacecraft hull, through the seat, through the body, through the skull, through the brain, and out the other side. The eye is only one of the places they pass through. They are crossing every cell in the body at the same time. The flashes are simply the only effect the body can perceive in real time. Everything else happens silently, at the level of damaged DNA, displaced atoms, and microscopic ionization tracks that the body will spend weeks repairing once the crew is back inside the magnetosphere. This is happening to you right now, very faintly, on the surface of the Earth. A small number of cosmic rays make it through the atmosphere and the magnetic field and reach the ground. But the rate is so low that your eyes essentially never see a flash. Out beyond the shield, the rate jumps by orders of magnitude. The Artemis II crew was the first group of humans in over 50 years to experience that escalation directly. They are now part of a club of fewer than 30 people in history who have seen cosmic rays with their own eyes. The second thing they did not put on the press kit is what the lunar surface actually looks like with no atmosphere between you and it. When you look at the Moon from your backyard, you are looking through about 60 miles of air. That air blurs every edge, softens every shadow, scatters every photon. Even the sharpest telescope on Earth fights that haze. The crew of Artemis II did not have that problem. They had no air at all between their eyes and the lunar surface, and at their closest approach, they were nearer to it than New York is to Los Angeles. What they saw was something that does not exist anywhere on Earth: pure contrast. The sunlit side of every crater rim glowed bright white. The shadowed side, just inches away across the same rock, was completely black. Not dark, not dim. Black, the way a hole punched in paper is black. There was no transition between the two. On Earth, even in Death Valley at noon, there is always a little bounce light, a little scatter from the sky that softens shadows. On the lunar surface, there is none. The result is a landscape that looks less like a real place and more like a printed image where someone forgot to render the midtones. That razor edge between light and dark is the consequence of one physical fact. The Moon has essentially no atmosphere. No air, no moisture, no dust suspended in a sky to diffuse anything. Sunlight either hits a surface directly or it does not, and the geometry is brutal. Mission imagery from Orion shows craters where the floor is so deep in shadow that the cameras cannot recover any detail at all. The crew, looking with the human eye, which has far more dynamic range than any camera ever flown, could sometimes see deeper into those shadows than the photographs show. They reported looking down into pits that seemed to have no bottom, where the blackness simply continued past the limit of what the eye could resolve. There is a specific reason some of those shadows are absolute. Near the lunar poles, certain crater floors have not seen direct sunlight in over 2 billion years. They are called permanently shadowed regions, and the temperature inside them can drop to around -410 degrees Fahrenheit, colder than anything on the surface of Pluto. That is so cold that water ice, if it lands there, can sit on the surface indefinitely without ever evaporating. Recent missions have confirmed that some of these regions contain frozen water deposits that may be older than complex life on Earth. The Artemis II crew flew too far north of those polar craters to look directly into them, but they did fly over terrain where the same effect plays out at smaller scales. Any crater deep enough, any overhang sharp enough, can produce its own miniature permanent shadow. From orbit, those shadows look like ink spots scattered across a grey page. The pictures you saw on the news flattened all of that out. Press images get color corrected, gamma adjusted, and balanced for the screens we own. The actual visual experience of looking at the moon from a few thousand miles up is something no monitor can reproduce. The crew described it as looking at terrain that did not feel real. Sharp where Earth is soft. Empty where Earth is full. Silent in a way that is more than acoustic, because even the visual texture of a place on Earth carries the suggestion of weather. There is no suggestion of weather on the moon. The rocks have been sitting there, unmoved, for billions of years. The lack of atmosphere also does something to color. The moon is often described as grey, which is roughly true, but the grey is not uniform. From up close, the surface ranges from a dark charcoal in the Maria to a lighter, almost tan shade in the highlands. There are reddish patches where iron-rich materials are exposed. There are bluish patches where titanium concentrations are higher. The human eye can pick up these subtle variations, and the Artemis II crew reported seeing them clearly. Photographs taken through camera filters often exaggerate or wash out those tones, depending on how the image is processed. The actual visual experience is more like looking at a stone surface in extremely sharp directional light, where every mineral inclusion casts its own tiny shadow, and the eye can see textures down to the limit of what its resolution allows. That texture, that unforgiving sharpness, is the second thing the crew did not really get across to the rest of us. You had to be there. They were. The third observation is the strangest of the three. The crew of Artemis II became the first humans in over 5 decades to see the lunar far side directly with their own eyes. And the far side is not the moon you think you know. The side of the moon you can see from your backyard is the near side. It is dominated by dark grey patches called maria, the Latin word for seas, even though they contain no water. The maria are vast plains of solidified basaltic lava, smooth and dark, and they are what create the patterns your brain interprets as a face or a rabbit when you look up at a full moon. They are also unequally distributed. The maria cover about 31% of the near side. On the far side, they cover roughly 1%. Look at the far side and the map stops making sense. There are almost no dark plains. There is no familiar face. Instead, the entire surface is highland terrain, lighter in color, brutally cratered, with craters packed inside craters going back over 4 billion years. The crust on the far side is also significantly thicker than on the near side, in some places by tens of miles. Scientists have theories about why. The leading explanation is that the near side, facing the early Earth when both bodies were young and hot, cooled differently because of the heat radiating off our planet, which allowed more lava to break through to the near side surface. There are competing theories involving a second, smaller moon that may have collided with the far side billions of years ago and merged with it. Nothing is settled. The crater density on the far side is also harder to process from up close than from a map. From the ground, on Earth, a crater is a recognizable shape. You can stand on its rim and see its floor. On the lunar far side from orbit, what the crew saw was a surface where almost every crater they could pick out had smaller craters inside it. And those smaller craters had even smaller craters inside them, all the way down to the limit of visual resolution. The surface is fractal in a way that the near side is not. The Maria on the near side resurfaced large areas over 1 billion years ago, erasing the older craters underneath. On the far side, nothing got erased. Every impact for the last 4 billion years left a mark, and they are all still there, stacked on top of each other. The Artemis II crew passed almost directly over the South Pole Aitken Basin, one of the largest and oldest impact craters in the entire solar system. It is about 1,600 miles across and roughly 8 miles deep. You could drop the entire state of Texas into it and still have room left over. The crater is so old and so deep that the impact may have punched through the lunar crust and exposed material from the moon's mantle, the layer that is normally buried hundreds of miles below the surface. The crew did not see the mantle directly, but they saw the basin end to end, from an angle no Apollo crew ever flew. The scale of that basin is hard to understand without something familiar to compare it to. The deepest point in the ocean on Earth is the Marianas Trench, about 7 miles down. The South Pole Aitken Basin is deeper than that, and instead of being a narrow trench, it is a circular crater, roughly the distance from Los Angeles to Chicago wide. If a comparable impact happened on Earth, it would crack the planet. The Moon survived because it was already an old body when this impact occurred, and because Moon's crust, despite the damage, was thick enough to absorb the blow without breaking apart. The crew flew over it in a matter of minutes. From their altitude, the rim curved away below them on both sides, and the floor of the basin spread out as a slightly darker shade than the surrounding highlands, marked with secondary craters and ancient lava flows that filled some of the lowest points. And here is the part almost no one talks about. From their vantage point on the far side, there was no Earth in the sky. Anywhere. The moon was between them and home. For the first time in their lives, and for only the second time in human history after the Apollo cruise, they were in a place where the Earth was not in their visual field at all. Not as a disk, not as a glow, not as a reference point. Just the moon below them, the stars above them, and absolute black behind them. That sensation, the sensation of being on the wrong side of the moon from Earth, is something no simulator can reproduce. It changes the geometry of where you understand yourself to be. It also has a practical consequence. While the crew was over the far side, they were in radio shadow. No direct line of sight back to mission control. Every astronaut who has ever flown beyond low Earth orbit on the far side has experienced this. The Apollo crews called it the longest silence. Communications routed through relay satellites can mitigate it now, but the basic geometric fact remains. For a portion of every far side pass, you are physically incapable of speaking to anyone on Earth because there is over 2,000 miles of solid rock in the way. The crew knew exactly when those windows would happen. They had timed them out to the second. But knowing that and sitting through it in the dark are different experiences. The silence is not just acoustic, it is structural. Earth, for those minutes, is not a place you can reach by any means. These are not classified observations. They are not even particularly secret. NASA released photographs, technical briefings, and post-flight summaries that include all of them in some form. But the things that made the news were the milestones. First crewed Orion. First humans past low Earth orbit since 1972. First black astronaut to reach the moon in Victor Glover. First Canadian beyond low Earth orbit in Jeremy Hansen. Successful heat shield performance. A bullseye splashdown. What did not make the news, in the way it could have, was what those 4 pairs of eyes actually saw. The cosmic rays writing flashes inside their skulls. The lunar surface stripped of atmosphere down to a contrast that the eye can barely process. The far side of the moon with no Earth in the sky, ancient and unfamiliar and silent. There is a reason astronauts tend to go quiet about these things in public. The official record is about engineering, about precedent, about whether the next mission can be built on the back of this one. The visual experience of being out there is harder to systematize. It does not turn into a chart. It does not feed a budget hearing. But it is what every human being who has flown beyond low Earth orbit has come home with. And now 4 more people have it, and the next crew will too, and the crew after that. The moon has been the same for billions of years. It has not moved. It has not changed in any way the human eye can detect. The only thing that changes is who is looking at it, and how close they are, and what their eyes have to work with. For 10 days in April, 4 people looked at it with no atmosphere in the way, with cosmic rays passing through their retinas as they did so, and with the Earth nowhere behind them. They came home, said the right things into the right microphones, and let the rest of the world go back to imagining the moon the way it has always been imagined. As a smooth white disk in the night sky. It is not a smooth white disk. It is a sharp, broken, ancient surface, half familiar and half completely alien. And it has been waiting up there for the next 4 sets of eyes to come see it the way it really is. Thanks for watching, and I'll see you in the next one.